Hello student, myself Mukesh Ganchi, Assistant Professor, Department of Mechanical Engineering. Today we start our fifth unit in Manufacturing Technology, which is based on High Velocity Forming Process. Now, topic to be covered, High Velocity Forming Methods, Hydraulic Forming, Explosive Forming, Electro-Hydraulic Forming, Magnetic Pulse Forming. Now, we start with High Velocity Forming Process. High velocity forming process is the group of metal forming techniques that use a high speed impact to shape the material, such as explosive forming, electromagnetic forming, and electrohydraulic forming. Now we see its definition. High velocity forming process are a group of manufacturing techniques that utilize high energy release to shape and form material at high speed. These processes are often used for forming complex shapes and geometries, particularly in materials that are difficult to form by using traditional methods. This diagram illustrating the high velocity forming process before the discharge of the explosive. This consists of the workpiece. This is the cavity under which we deform the material. This is the forming die which, which is under the this enclosure. When we trigger out this explosive will generate the shock waves which is directly impact on this workpiece, and this workpiece will directly deform or transform into the die cavity. Here we see the workpiece is directly changed into the shape of the die. Now in this slide we discuss the type of high velocity forming process. First one is explosive forming. This process uses the energy released from an explosive charge to shape a workpiece. Second type is electro-hydraulic forming. This process uses the energy released from the electrical discharge in the liquid medium to shape the workpiece. Third type is electromagnetic forming. This process uses the energy released from an electromagnetic field to shape the workpiece. In this slide, we discuss the major advantages and application of high velocity forming process. The major advantages of high velocity forming process are to form complex shapes and geometries, high precision and repeatability, ability to form high strength of material. It improves the material properties. It reduces the tooling cost also. It increases the productivity. Application of high velocity forming process are it's used in automotive body panel, aerospace structures, medical implement and devices, electrical components, and consumer electronics. Now we discuss the explosive forming. The explosive forming process is a high velocity forming techniques that use the energy released from an explosive charge to shape the workpiece. This process is often used for forming complex shapes and geometries, particularly in materials that are difficult to form by using traditional methods. Types of explosive formings are unconfined type, which is also called as standoff techniques. Second is confined type, which is also called as contact technique. In this slide, we see the principle of explosive forming. This diagram illustrating the explosive forming process. This consists of this explosive. This is the workpiece. This is the die cavity which connected to this vacuum line. When we figured out this explosive, the shock waves are generated and these shock waves are directly impact on this workpiece. After this, the workpiece is directly deformed or transformed into the shape of this die. The work is firmly supported on the die and the die cavity is evacuated. A definite quantity of explosive is placed suitably in the water medium at a definite standoff distance from the workpiece. On detonation of an explosive charge, a pressure pulse or a shock wave of a very high intensity is produced. A gas bubble is also produced which expands spherically and then collapses. When the pressure pulse impinges against the workpiece, which is the plate or the sheet, the metal is deformed into the die with a high velocity of around 120 meter per second to 130 kilometer per hour. Now we see the advantages of explosive forming. The shock wave is efficiently transmitted through water and energy is transmitted effectively on the work. Less noise is produced during this process. Less probability of damage to work. Large and thick part can be easily formed. Economical when compared to hydraulic press. Now we discuss the electro-hydraulic forming process. This is this diagram illustrating the process of electro-hydraulic forming. This process uses the energy released from the electric discharge in a liquid medium to shape the workpiece. This consists of a charger which is directly connected to this capacitor bank. The electric discharge creates a shock wave that deforms the workpiece into the desired shape. When we on the switch, and then the electrical energy is directly impact on this workpiece and the workpiece is regain the shape of this die or transform into the shape of the die. In this slide, we discuss the principle of electro-hydraulic forming. A sudden electrical discharge in the form of spark is produced between the electrodes and this discharge produces a shock wave in the water medium. This shock wave deforms the work plates and collapses it into the die. The characteristics of this process are similar to those of explosive forming. The major difference, however, is that a chemical explosive is replaced by the capacitor bank, which store the electrical energy. The capacitor is charged through a charging circuit. When the switch is closed, a spark is produced between the electrodes and the shock waves or the pressure pulse is created. The energy released is much lesser than that released in the explosive forming. The process characteristics are standoff distance, it must be optimum. Capacitor used, the energy from the pressure pulse depends on the size of the capacitor. Transformer medium, usually water is used as a transferring medium. Vacuum, the die cavity must be evacuated to prevent adiabatic heating of the work due to a sudden compression of the air. Material property with regard to application of high rate of strain. Now we see the advantages of electro-hydraulic forming. The first advantage is its better control of pressure pulse as a source of energy is electrical, which can be easily controlled. It is safer in handling than the explosive material. more suitable if this work size is small to medium. Thin plate can be deformed with smaller amount of energy. The process does not depend on electrical properties of the work material. The limitations are: it is suitable only for smaller work. Its need for vacuum makes the equipment more complicated. Now we discuss the electromagnetic forming process. Now see its introduction. The electrical energy stored in the capacitor bank is used to produce opposing magnetic field around a tubular work piece surrounded by the current carrying coil. The coil is firmly held and hence the workpiece collapses into the die cavity due to magnetic repulsive force or magnetic repelling force, thus assuming a die shape. This is the diagram of electromagnetic forming process, which consists of a eddy current coil. This is the eddy current coil. This coil are firmly held and hence the workpiece is collapsed in between the die cavity due to the magnetic repulsive force is produced, which is directly impact on the workpiece, and the workpiece will regain or transform the shape of the die. Now we see the process details, steps of electromagnetic forming process. The electrical energy is stored in the capacitor bank. The tubular workpiece is mounted on the material having the die cavity produce the shape of the tube. A primary coil placed around the tube and the material assembly. When the switch is closed, the energy is discharged through the coil. The coil is produce a varying magnetic field around it. It is the tube a secondary current is induced which creates its own magnetic field in the opposite direction. The direction of these two magnetic fields oppose one another and hence the rigidity held coil repel the work into the die cavity. The work tube collapses into the die assuming its shape. The process parameter consists of workpiece size, the electrical conductivity of workpiece material or the work material, size of the capacitor bank, the strength of the current which decide the strength of magnetic field, and the force applied. Insulation of the coil, rigidity of the coil. Now in this slide we see the advantages of electromagnetic forming. It is suitable for small tubes. Operation like collapsing, bending and crimping can be easily done. Electrical energy applied can be precisely controlled and hence the process is accurately controlled. The process is safer as compared to the explosive forming. Limitation of electromagnetic forming: it is applicable only for electrically conducting material. Not suitable for large workpiece. Rigid clamping of primary coil is critical. Now we see the application of electromagnetic forming process. Its application used in crimping of coil, tubes and wire. Its application is in bending of tube into the complex shape. It is also used in bulging of thin tubes. Thank you.